All right, before we get into reactions, new reactions that make amines, we have to remember we have a lot of old reactions that make amines. So this is all in 23.2, review reactions that make amines. And there's a lot of other sections involved too, because this one's a reaction we use every test. Converting alcohols to organic bromides is accomplished using PBr3. We learned that way back in chapter 10. And in chapter 9, we learned you could do SN2 reactions on haloalkanes. You use KCN and DMF. And then in chapter 18, we learned that nitriles are derivatives of carboxylic acids, and they can be reduced to amines. Here's our first amine. NH2. And you know, it's all important about amines, so let's make them important here. Haven't used one of these babies in a long time. Little small. We just made a primary amine. And an amine is also a nucleophile. And we learned in chapter 11, you can open epoxides with a nucleophile. If they're strong or medium, like this one, a moderate nucleophile, primary amine, it's going to attack the least hindered position of the epoxide. And you'll pop it open. So here's your old epoxide. I'm going to draw what we get. Initially, you get this. I'm going to be editing this. So maybe copy everything up to here. And with the NH2, let's see. Copy up to there, because initially you're going to get this. Copy that. Do not copy what I'm about to copy. This H, don't copy it. Don't copy the plus charge. Don't copy the O minus. That's an intermediate. If you want partial credit, go ahead, give me the intermediate. You won't get full credit. I've got the conjugate base of an alcohol. The pKa of an alcohol, it's 17. I've got an ammonium ion right here. The pKa of an ammonium ion is 10. If there's a possibility of 10 going to 17, it will happen. And yes, the O minus reaches over and grabs the H and does an acid-base reaction. So this intermediate becomes this, where the extra H is now on the O and both the charges are gone. And now you have a secondary amine. Secondary amine. This one happens to be beta 2 and alcohol. Alpha beta. A beta hydroxyamine. How's that? Okay. Beta hydroxyamines like ethanolamine are common in biochemistry. This one's a little more complicated than ethanolamine. Let's finish this train off. What's PCC going to do to the secondary alcohol? Answer, oxidize to a ketone. That's the full answer. What happens to ketones with NH3? I'm going to do the steps here. Why not? Good review. 1, oxidation of alcohols. Check below. Oxidation of alcohols found in chapter 10. Keyboard, just random. So you're gonna get, I don't know. I'm gonna go back upstairs and circle this so I don't have to draw it again. How about all the way to the CH2, huh? You get your R, attached to your N, attached to H, attached to C, attached to carbonyl. There's step one. Step two, found in chapter 16. You're going to make an imine. Yes. Chapter 2 says an amine that's either primary or ammonia. This is ammonia. Step 2, it's ammonia. We'll make a double bond to the carbonyl carbon and the oxygen will disappear. Could have put DST in there to make it go even smoother, but I didn't. And you get NH2. Nope, double bond NH. Sorry, I'm looking ahead. Double bond NH, step 3 and 4. Step 3, I'll just show you. Step 3, H minus does its thing. And you get an N minus. Step 4, N minus becomes NH. And what you've got here is R attached to NH, attached to C, double C, double C, double C, attached to NH2. You got a purple H down here. You got a black H up here. And HCl, green H. There you go. Color coordinated for your mechanistic pleasures. Right there. And you made another secondary or primary amine up there, huh? And steps 2, 3, and 4 are called, this is not news, 2, 3, 4, reductive amination. Reductive amination. Remember that. So put a big asterisk on it. Okay, let's take the alcohol up here. We're back to the beginning. How do you make that into an aldehyde? That's on every test as well. PCC, we found that in chapter 10. Where did we see reductive amination? We saw it in chapter 16. And we're seeing it again, 23. Step 1, this time. Oh, I can't call it R. I changed the CH2. I thought I made that blue. Step 1 gives that. Step 2, reduction. Yeah. That's step 2. Up here, 1 and 2 are called reductive amination. Wow. Think it's important? You made an amine after you made either an enamine or an imine. and reduced it to an amine. All right. Reductive amination. And another chapter 9 reaction. And then a new reaction. Learn now. Oh, it's not the reaction I thought. Darn. There's a mistake. It doesn't give what's in that box. When I started this handout, I had that idea that it was going to give the same product. But then I decided I want a methyl on it for some reason. So that's going to go somewhere else. H2PT with this molecule, we need to find a new box. We're going to make a new box. Where do you want your new box? I want my new box right here. We're going to make a nice square box right here. Make it more square. Thank you. And we're going to make it orange arrow. Try to make it as neat as possible. Little neat. Thank you. Good. So what's going to happen with H2 and PT on that? It's a new reaction. We have to learn it now. But here's a clue. I think you know the product. And the product is going to be an amine. I'll draw the whole thing up. Although I could have called this R. So you get a primary amine, right? And we had a secondary amine here. And got a new primary amine up there. Down here we had an old secondary amine. Just pointing out all these new amines we made here. I never did the chapter 9 reaction. KN3, and I'll use DMSO this time. I want an SN2 reaction using azide. Yeah. I want to show what happens to get to this box in step 1. So how am I going to do that? I'm going to use my imagination. Cut off some of this box here, because I'm out of room. Yeah, it didn't work out very well, did it? Nice. So step 1 is going to give, I can use my R finally. R takes me up to the N, is attached to N, CH3, yeah, with a single bond to the, this is an enamine, enamine. Hey, guess what happens with H2 and PT in step 2, bless you. Final product, R, attached to N, That's the CH3. And that's a tertiary amine. Oh. There you go. And guess what 1 and 2 are called? Steps 1 and 2 here. 1, 2 equals. Reductive I knew so I was going to eventually fall for it. Amination. You want to say animation, right? It's like a dyslexic trap. And there's a P in there for some reason. Random. Bold. Make it something stands out a little bit. Move it over. Won't let me. Right up there. You think reductive amination might be on your test? Yeah. It's one of the best ways to make amines. You can go from an enamine or you can go from an imine. Imine here, imine here. You can reduce them with NaBH4 and HCl. That's what I did to the imine here. That's steps 3 and 4. Or you can use H2 and PT. They both work interchangeably. H2PT or sodium borohydride HCl. They'll reduce the imine or the enamine. Is that clear? So I could have replaced H2PT here with NaBH4 followed by HCl. I could have replaced NaBH4 followed by HCl here with H2 and PT. They would be okay. They would work. Same result. End of story.